Here we have a unique carbonate that's not pedogenic. It's from the groundwater when the Rio Grande was here. So pedogenic is this interaction with the atmosphere. This groundwater carbonate, to throw out a 10-cent word, is called phreatic. And phreatic carbonate has different dynamics, but it's still a carbonate. If you go down and dig into that, you'll see the fluvial facies, but we don't see the gypsum. This is not part of what was the basin lake, the Lake Jornada. Here, it's more the interaction of the Doña Ana's coming off. One phenomenon that happens within geomorphology, the closer you get to the source, the larger the sediment or gravel content. And you could see where that happens, of where we trigger from this kind of lighter gray vegetation up into the creosote, which is that greener shrub that you see kind of in the distance. We saw at the first pit with aeolian activity, but here with alluvium, with essentially sheet flows that would come off the Organ Mountains. If we were to remove all of that river fill, this would be, I think, twice the size of the Grand Canyon, both in depth and width. And to put it in scale, when that river tipped over into the Tularosa Basin to the east, you can imagine just how wide that floodplain is of tipping over and starting to fill up the next basin. Some block diagrams and some data. The block diagram, I'm going to start with first. We talked about the Upper La Mesa, which is up where the airport is. What happened there is, as part of the basin range faulting, that surface was faulted up out of the Rio Grande floodplain. So there, pedogenesis started earlier than here. This color is essentially the experimental field that's in front of us. If you are to face it north, so hold it like this, I think we are essentially here at the bottom of block 3, looking at it. So this is Leindecker Farm. It's one of the experimental farms for New Mexico State University. And this field is the soil health demonstration plot.